Good morning. Today we're looking at section 6.2, wireframes, partial derivatives, and tangent planes. The basic idea we're looking at is looking at functions of two variables and trying to obtain information from related functions of one variable. We're going to start with the problem that was done in the last section, where I'd like to produce two products, widgets and gizmos, and I've given the demand functions for widgets and gizmos. I can turn that into a revenue function in terms of the quantity of gizmos and the quantity of widgets, because the revenue from gizmos is going to be the quantity of gizmos times the price of gizmos. And similarly, we're going to have the quantity of widgets times the price of widgets, and that will give us the revenue from widgets. We add the two of them together and get the revenue from both selling gizmos and widgets. We can turn this into an Excel worksheet where I have the formula down, my quantity of gizmos is across the top, my quantity of widgets is down the side. Notice that anytime I had a quantity of gizmos, I look up, in this case to B3. I've got $3, because when I transfer across and drag, I like the B3 to turn into a C3. And similarly, if I'm looking at the quantity of widgets, those will all be in column A. So I'm going to keep column A there by putting the $sign in front of the A, but it goes from row 4 to row 5. We can unshow the formulas, make our sizes more appropriate for the rows. I then do quick fill, and that will build my table. I'm going to look at the quantity of gizmos against the revenue when the quantity of, I've got the quantity of widgets. I'm assuming the quantity of gizmos is 300. I look at that. I insert a smooth scatter plot, and this gives me the revenue in terms of the quantity of widgets, assuming my quantity of gizmos is 0, is how to take these lines here and turn them into something more useful. We're going to look at this chart and change the chart type. It's a surface. The kind of surface graph we want is a wireframe graph initially. The graph is made up of these wires that correspond to the graphs we had before. I'm now going to look at this in terms of a different application called GeoGebra. As you can see, I have a nice graph of the 3D surface. I'd like to look at what happens if we cut that by a plane. And so I have a fixed plane where the quantity of widgets is 300, and I see the graph that I get from the fixed plane. So this is the graph, and if I move the 300 back, if I move the quantity of widgets back and forth, that turns into a number of different curves along this. I can build that into a mesh, and if I remove the surface, I get a good idea of what's happening with the surface by looking at these functions of one variable, which I already know how to deal with. I just plot them in the appropriate plane. If instead of doing the slices when GW is fixed, I now fix when the quantity of widgets is fixed, and I'm going to look at the slices the other way. Once again, I build a mesh where the plane has interacted with the surface, and the two of these together, I now take the plane away, I get a wire mesh. If I remove the surface, I still have a good idea of what the surface is by looking at this wire mesh. So the main idea of this example is that I can do a good understanding of a function in two variables by building together a mesh of functions in one variable. That's all for today.